If you recall our discussion on carbohydrates, carbohydrates are composed of the monosaccharide building blocks. So in the case of lipids, they also have their own building blocks. Now, these building blocks are the fatty acids. So by definition, fatty acids are naturally occurring monocarboxylic acids with linear or unbranched carbon chain. So unlike carbs, wherein some types of carbs have branches, all fatty acids occur in linear carbon chains, so all of them do not have branches within their structure. And it is important to note that fatty acids are naturally occurring monocarboxylic acids. So what does this mean? So if we take a look right here, okay, so if we take a look right here, it is said in the definition that fatty acids are monocarboxylic acids. So this part right here, this one, this COOH at the right end part of our chain is the carboxylic acid group contained in your fatty acids. So it stays true with the definition that fatty acids are indeed monocarboxylic acids because of these groups right here. So these are the carboxylic acid end of the fatty acid. Now going back, okay, going back to this one, fatty acids usually have an even number of carbon atoms. So for long chain fatty acids, these are the fatty acids that has 12 to 26 carbon atoms. For medium chain fatty acids, these are fatty acids that have 8 to 10 carbon atoms. And short chain fatty acids are those that have 4 to 6 carbon atoms. Now, we classify fatty acids into two categories, and these are the saturated and the unsaturated fatty acid. Now, the difference between the two is very easy. For saturated fatty acids, these are the fatty acids that do not contain double bonds. Therefore, all carbon-to-carbon bonds are single bonds, whereas unsaturated fatty acids are those that do contain double bonds. And these could be further classified as either monounsaturated or polyunsaturated. The difference between the two is that for monounsaturated, there is the presence of one double bond, one carbon-to-carbon double bond, and in polyunsaturated fatty acids, there are more than one carbon-to-carbon double bonds present. So always remember the difference between the saturated and the unsaturated, and the monounsaturated and the polyunsaturated fatty acids. Now moving on. Okay, so as I have told you earlier, fatty acids with a carbon chain in which all carbon-to-carbon bonds are single bonds are those saturated fatty acids. So we have here the structural formula for the saturated fatty acids. So, kaning pinakataas, this one right here is a detailed structure formula for the saturated fatty acid that has the common name palmitic acid. Okay, so as you can see from here, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 carbons within the carbon chain. So this is a long chain fatty acid. Now, the structural formula for fatty acids could be written in three different ways. So this being number one. This is number one, a detailed structural formula. And these two right here are a more condensed structural formula for the fatty acids. However, we can always represent fatty acids in these three different ways. So we have here detailed representation, so like this one. We have here a more condensed representation, this one, CH3. This methyl end right here is this part right here, this one. This CH2 14 right here is this one, this one. So meaning there are 14 carbon atoms, each with two hydrogen atoms attached to them. And then lastly, this one in yellow is again the carboxylic acid end, the COOH. Now, if we take a look at the third representation right here, we could have this zigzag-like pattern wherein each point indicates a carbon atom, like that. Okay, so again, fatty acids can be represented using any of these three representations. Moving on. Okay, let's now go to the unsaturated fatty acids. So as I have told you earlier, unsaturated fatty acids are those fatty acids that has the presence of one or more double bonds in the structure. Now let's talk first with the monounsaturated fatty acids. So these are fatty acids with one carbon-to-carbon double bond. Now, like my previous illustration, this can also be depicted in the three different representations. So it could be either in this detailed representation right here, or it could be either represented using this more condensed representations at the bottom. Now take a look. Notice how the double bonds in the structure is highlighted in pink. So as you can see in this detailed representation right here, inyong ma-observe na the chain is somewhat not branched, but bent. Okay? Medyo siya na bend. That bending is because of, is a result of the double bond present right here. Okay, so remember this one. The bending is caused by the double bond present within the structure. Okay, now for the second representation, okay, it is just represented using two dashed lines. Whereas for the third representation in this zigzag-like pattern, okay, instead of um, having points here, you can see that the double bond right here is indicated this way. Okay, so this fatty acid is or has a common name oleic acid, or um, it also has the IUPAC name cis 9-octa decanoic acid. Now, notice how this fatty acid is named cis fatty acid, CIS. Now, the cis notation there is because of the hydrogen atoms attached right here in your carbons connected using a double bond. So, lantawa ang hydrogen atoms na naka-attach to your carbons having the double bond. Okay, so as you can see, two or both of them rather is on the same side of the chain, correct? So because they are on the same side of the chain, we use the cis annotation. Now say for example, one of the H is on the opposite side. Like for example, we have here the H is going down right here and not here. So if this is the case, if the hydrogen atoms connected to your carbons having the double bond, you use the trans annotation. Trans. So this is for opposite. Okay, moving on. We have here polyunsaturated fatty acids, meaning there are more than one carbon to carbon double bonds present in the structure. So there are up to 6 double bonds present in some biochemically important polyunsaturated fatty acids. Okay, moving on, we have here the double bond position in unsaturated fatty acids. So we use a numerically based shorthand system for specifying key structural parameters for fatty acids. So this system uses two numbers separated by a colon. Okay, so the structural notation indicates number of carbon atoms and the number of carbon to carbon double bonds. So for example, we have here this numerical notation 18 colon 2. So this would tell us that in that fatty acid there are 18 carbons and 2 double bonds. Okay. So another example, say for example that our numerical annotation is, say for example, 16 colon uh, 3, for example. So this would tell us that there are 16 carbon atoms and 3 double bonds in that fatty acid. So always remember this two-numbered numerical notation for fatty acids. So the first number tells us about how many carbon atoms is present in the chain, and the second number tells us about how many double bonds is present in the chain. Now furthermore, to further specify, if ato pa yung i-specify kung asa nakaposisyon ang double bonds present in the structure of that unsaturated fatty acid, we use the Greek capital letter delta, this one, kining murag triangle, followed by one or more superscript numbers. Okay, so again, the Greek capital letter delta tells us the specified or the exact position of the double bonds present in your chain of unsaturated fatty acids. So say for example, we have here, okay, we have here, say for example, this one. The notation 18 colon 3 delta 9 12 15 denotes an 18 carbon polyunsaturated fatty acid. PUFA here is just an acronym for polyunsaturated fatty acid, PUFA, with 3 double bonds located between carbon 9 to 10, carbon 12 to 13, and carbon 15 to 6. Okay, so take a look. The delta notation tells us about the position of the double bonds in the chain. So take a look at this one. Delta 9, 12, 15. Meaning, buot pasabot ani is that the first double bond is located after carbon number 9. The second double bond is located after carbon number 12, and the third double bond is located after carbon number 15. Now, the numbering of carbons would start from the carboxylic acid end. Diri ta magsugod og count sa carbons sa ato ang carboxylic acid end. There is a COOH. So the carbon here, this is carbon number 1, okay? Carbon number 2, carbon number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So again, we number the carbons starting from the carboxylic acid end if we are using the delta annotation. So remember this one. For delta annotation, we count the number of carbons from the right-hand side, from the carboxylic acid end. Okay. So say for example, later in our exam, I would ask you to find which of the following unsaturated, polyunsaturated fatty acids has the numerical annotation 12 colon 2 delta 3 6 9. Okay, so say for example, I have that question in the exam. So you just have to locate, or you just have to count the number of carbon atoms, the number of double bonds, and find the position of the double bonds in the structure. Okay, moving on. Okay, however, there are certain families of fatty acids that exist in which the position the position of the double bond is not related to the carboxyl end or the COOH, but from the opposite end. Okay, so let's go back to our illustration. Naa daw yung families of fatty acids. Let me just erase the. Okay. Okay. So there are certain families daw guno of fatty acids wherein we count or we relate the positions of the double bonds not from the carboxyl end but from the opposite end. So dili ta diri magsugod o count sa position sa double bond but from here, from the opposite side, or specifically from the methyl end. Again, remember that this is a methyl end, right? Because we have here carbon, H, an H here, and an H right here. So there are certain fatty acids daw guno wherein we relate the position of the double bonds not from here, but from here, from the methyl end. Okay. Now, if this is the case, if we count the position of the double bonds from the methyl end, we now use the notation or using the Greek lowercase letter omega. Okay, so if we count the position of the double bonds from the methyl end or from the left side, we use the Greek lowercase letter omega. So again, delta is for the carboxyl end, or from the right side, whereas omega is for the methyl end. Or from the left side. Okay, so that is the difference between using the Greek letters delta and omega in determining the position of the double bonds. Now, okay, illustration for that example would be this one. We have here the omega-3 fatty acids. So as you can see, the double bond is counted not from the carboxyl end but from the methyl end. So as you can see, the first carbon or carbon number 1 is this carbon right here, carbon number 2, and the first double bond is present after carbon number 3, which is why this chain of fatty acid is named as omega omega-3 fatty acid. Okay, so we also have here this one, the omega-6 fatty acid, an unsaturated fatty acid with its endmost double bond 6 carbons away from its methyl end. Okay, so as you can see from here, the first double bond is um, after the sixth carbon atom. Okay, so if we take a look right here, wait, this shows the names and the structures for some biochemically important fatty acids. Where is that? Okay, Tara. So as you can see from here, this shows the names and structures of some biochemically important fatty acids. So zooming in. Okay, so I hope you can see the illustrations clearly. Oops. Okay. So over here, saturated fatty acids. So the numerical notation is 12-0. Both pasabot, there are 12 carbon atoms and 0 double bonds. So all saturated fatty acids would have 0 as the second number in the numerical annotation. And wala na delta or omega notation again because there are no double bonds in their structure. So we only use the delta and the omega notation for the positions of the double bonds. Now, because these are unsaturated fatty acids, we we don't use or yeah, we don't use the delta and the omega notations. Now going to the monounsaturated fatty acids, we have here the notation 16 colon 1. Both pasabot, there are 16 carbon atoms and 1 double bond. Now, asa na position ang double bond? We take a look at the delta notation. So from the side or from the carboxyl end, the double bond is after the ninth carbon. Now, if we use the omega notation, which is side, the double bond is after the seventh carbon. Now, second, we have here, wait. Okay, so second monounsaturated fatty acid right here is this one, 18 colon 1. So meaning there are 18 carbons and 1 double bond. Now where is the double bond positioned? Take a look at the delta notation. So from the carboxyl end, the double bond is situated after the ninth carbon. Whereas for the omega notation, from the left side, the double bond is situated also after the ninth carbon. Now the common name for this fatty acid is the oleic acid. Now for the polyunsaturated fatty acids, we have here this numerical notation 18, 2, meaning there are 18 carbons and 2 double bonds. Now, where are the double bonds positioned? Take a look at the delta notation. So from the carboxyl end, the first double bond is located after the ninth carbon, and the second double bond is located after the 12th carbon. Now from the left side or from the methyl end, we have here the notation omega 6, meaning the first double bond is located after the sixth carbon. Okay. Now for the omega notation, there is no need to include the other double bonds in the numbering. So you just number the first double bond. That is for the omega notation. So second, we have here this 18, 3. 18, that is because there are 18 carbon atoms. 3, that is because there are 3 double bonds. Now the positions of the double bonds is indicated by the delta and the omega notations. For the delta notation, we can see from here that the first double bond is 9 carbons away from the carboxyl end. The second double bond is after the 12th carbon atom, and the third double bond is after the 15th carbon atom. Now, if we count from the methyl end, that would be an omega 3 fatty acid, or the linolenic acid. Okay, so that's it. That is how you determine the position of double bonds in mono and polyunsaturated fatty acids and using or determining the numerical structural notations using the two number separated with a colon. So please always remember that one.